Okay, it is day 3 of Advent, and that means we have another 2 challenges to complete today as we make our way through the 25, maybe we'll make our way through the 25 Advent of Code challenges. We've done 4 already. I've got 4 stars to my name here. We got 2 in day 1 and 2 in day 2, and hopefully we'll be able to get another 2 today in day 3. So let's have a look. And this picture's starting to take shape as well. I'm not quite sure what it is yet, but interesting. Normally it's like a Christmas tree or something. This one's a little bit more interested to see how this one develops. Let's have a look at what day 3's challenge is. Okay, day 3, toboggan trajectory. With the toboggan login problems resolved, you set off towards the airport. Oh yeah, we're on the way to our holiday here. This is the kind of context of these challenges. While travel by toboggan might be easy, it's certainly not safe. There's very minimal steering and the area is covered in trees. You'll need to see which angles will take you near the fewest trees. Oh, this is already sounding like it's going to get messy. Okay. Due to the local geology, trees in this area only grow on exact integer coordinates in the grid. Obviously, that's how trees work. They only grow on exact integer coordinates in the grid. That's just how rocks work. You make a map, which is our puzzle input, of the open squares, which are represented by dots, and trees, which are represented by hashes that we can see. For example, we'd have this. So with the empty spaces and the trees. These aren't the only trees, though. Due to something you read about once involving arboreal genetics and biome stability, the same pattern repeats to the right many times. Okay, so we can see that this overlaps over and over and over again. Oh, blimey, what have I got myself into? Okay. You start on the open square in the top left corner and need to reach the bottom below the bottommost row on your map. So we need to go from this top left here to somewhere on the bottom here. Below the bottommost row. Okay. The toboggan can only follow a few specific slopes. You opted for a cheaper model, dang it, that prefers rational numbers. Start by counting all the trees you would encounter for the slope right 3, down 1. From your starting position at the top left, check the position that is right 3 and down 1. Then check the position that is right 3 and down 1 from there, and so on until you go past the bottom of the map. The locations you check in the above example are marked here with 0, where there was an open square, and X, where there was a tree. Okay, so we go right 3, so we're at position 1, and then we go 1, 2, 3. So right 3, and then we go down 1, and we end up here. And they've put a 0 there to signify that that's where we've got to. And then we go again. So we go right 3, 1, 2, 3. I can't highlight these very well. And then we go down 1, and we get here. And there was a tree here, so they've put an X. And then we go right 3 and down 1, and a 0. Right 3, down 1, X. Right 3, down 1, X, and so on and so forth until we get down to here. In this example, traversing the map using this slope would cause you to encounter 7 trees. Starting at the top left corner of your map and following a slope of right 3 and down 1, how many trees would you encounter? Okay. Interesting. Okay. So this pattern is repeating itself, and that is the key thing. The thing we need to bear in mind is that we've got this thing here, and this repeats itself infinitely. So every time we go right 3, down 1, we're going to come across and we're going to be kind of looping back around to the start. So we could think, if we were at this hash here, we could think about going right 3 as going 1, 2, 3, and ending up at this hash. Or we could think about it as going 1, and then coming back to the start of the line, 2, and 3, and ending up at this hash, which is the same position, really. Yeah, so we don't need to map it out like this in our program. We just need to make sure that we can loop back round. I think that's going to be the thing to do here. Okay, let's get to this. So to begin, let's get our puzzle input. Now this is going to be hardcore. Okay, this is going to be nothing like this. This is child's play what they've given us here. Let's see what our puzzle input is. Oh my goodness. Oh my goodness. No, it's so long. Oh, no. If only we had a computer we could program to do this for us. Okay, so we're going to start this top left corner and we're going to toboggan our way down this hill. All these hashes are trees, and we're going to count the amount of trees that we're going to smash into on our toboggan. What a lovely time to be alive. I'm just going to hit Control A there to select everything, Control C to copy it, and I'm going to jump into REPL.it and whack my data in. So I've got my day 1, my day 2, I've got my day 1's data, my day 2's data. So let's just get set up here. So let's add a new file. Let's make day3.py. And let's also make day3data.txt. And let's paste that in. Wabam. We're in. Fantastic. So Control V, paste that in. 323 lines of dots and hashes. Wow. Wow, wow, wow. Okay. So day 3, what are we going to do? Well, firstly, we're going to steal some code from day 2. We're going to take this, and we're going to take this comment as well. I'm going to update this comment with what we want to do for day 3. So in this example, how many trees would you encounter? So let's just take this, and let's just put it in our code so we remember what we're doing. Oh, goodness. Okay, here we go. Let's get rid of these files as well because we're done there. So I made this helper yesterday. So if you were here yesterday, you would have seen me make this little file. I've called it helper.py, and I've got a little function in here that will read my file. So I can just use this. I can import it into day 3, and I can use that to read my file. It basically means that I don't have to just keep copying this file and pasting it into each day and like having that function there. What I can actually do is just say helper.read file, and that is much easier. So let's just pop that there. So advent of code, day 3. Does this run? Bash? Nope, day 2 is running still, so I just need to update this in .repl.it. I don't know why I call it that, /day 3. There we go. And now I should be able to hit run. Okay, day 3. Great, we did a line of code. Should we stop there? No, let's carry on. Let's carry on. So we've got our data here. So our data is going to equal helper.read file, and we're going to read in our text file. So day3 data.txt. So day3 data.txt. Lovely. And what that's going to do is it's going to load our data in. Now, if you've been watching along for the last 2 days, I don't actually start with that. What I start with is just the little easy data, the little example data, because this is much nicer to start with. So let's grab that, and let's say actually our data, let's call it test data. Test data is equal to, and let's just pop this in here. Now I'm going to have to do a quick bit of shenanigans. Can I? No, I can't do that. Can I do this? No, can't do that. I want to select each. Well, okay. I'm going to just pop a speech mark on the start of each line. So they're all as strings. We're going to automate this, but I'm just going to do this the long way. Oh no, it's trying to be clever now. Hang on, go. Nightmare. Start at the top. Genuinely really frustrating. Are you doing this to me? Okay. And we're going to pop these into a list. So we're going to say this is our first one, and then we're going to say this is our second one, this is our third one, and so on. So these are our different rows of our. Actually, I don't need to put them in a line like that. Let's do it like this. So let's pop them all like that, and we're going to grab all of these, shunt them across, and then just put commas after them. And we're going to say, yeah, these are all in the list here. And the reason I'm doing this is so that we can test this with some data that we know is correct. So we know that we are going to have, if we come down to the bottom here, we're going to hit 7 trees. So if our code works with this little test data and we get the result of 7, then we're golden. So this all looks good. Now what we're going to do is we're going to start writing our program to look through this. So we're going to start at this position here, which will be at position 0 in test data. And inside this string, it's also going to be at position 0. So we're going to have a position, and that position is going to be equal to 0, 0. Okay, so it's going to be the 0 first row, or so at position 0, first row, and it's going to be the first thing in that, so at position 0 here. And then when we have to move 3 and down 1, we'll then add 3 to this one, so this will be 3. No, it won't. We're going to add 3 to this one. So this will be 3 and this will be 1. So we'll go to the next one down and we'll go 3 along. So this is 0, 1, 2. And so this dot here will be the third one. And we can see in the example that that is where we end up here in our first move. So each time our position is going to update. So let's do that actually. Let's make a function called update position. Oh, let's do that. And we're going to pass in the position and we are going to return, no, we're not, we're going to say position at 0. So this one here, this number here, we need to add 1 to because we want to go down a row. Okay, so we're going to say position 0 equals position 0 plus 1. Now, for this one, for going right, we're going to go right 3 steps. But when we get to the end here and we go 1, 2, we then need to check if we're at the end, we loop back round. So we're going to have to do something a little bit more clever for position 1. So this will be at place 1 in our array. So this position 0 will be equal to 1 here, and position 1 will be equal to 3 here. And so we're going to say is equal to position 1 add 3, because it's telling us that we need to move 3 to the right and 1 down. So following a slope of right 3 and down 1. So every time we go through this, we're going to go right 3 and down 1. So we're going to add 3 to our position. Now we need to do a quick check. We need to say if position 1 is greater than or equal to the length of position. No, not the length of position. The length of our test data. What should we do there? We need to pass in the length, really, don't we? So we need to give update position a max width. Let's call it that, max width. So we need to work out what the length of this is, this string here, and give that when we're updating the position, because we don't want to be greater than the max width. So if our position is greater than the maximum width, which in this example here will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if it's greater than or equal to 11, we're then going to make it wrap around. So we're going to say, what are we going to say? We want the remainder from the max width. So we want to say position 1 modulus max width. And what modulus is going to do, it's going to give us a remainder. Oh, but what if it's 0? Actually, no, this is stupid. This is really stupid. We can do it much simpler. So we can say we want to do our position 1 wants to minus max width. And we're going to say position 1 is now equal to, so if our position became 12, okay, but this is only 11 long, we want to reduce our position back to 0. So we're going to do 12, that's too long. It can only be a maximum of 11. So we're going to do 12 minus 11, and that will give us 1. But actually it needs to be at position 0, so we need to minus another 1. Okay, and then what we're going to do is we're going to return our position. So I'm going to rename this to current position. And now when we can run this function, and we can just say something like current position. No, sorry, we can say update position. We can give it our current position, and we can also give it a max width, which is 11 at the moment. We'll get that to calculate it. And we can say our current position is now equal to update position. We pass in what our current position is, and we give it the width. And then our update position function will take that current position that we've passed in there. It will take this width that we've passed in there, and then it will update our position. It will do a bit of logic to calculate whether it needs to wrap back round again, and it will return our position back here. So we'll get a new updated array with our two XY coordinates in. This is like a grid, really, isn't it? So this is our row position. What row is it on inside here? And then it's our column position. So what column is it in? So we've got a little function there. What we're going to do is just pop that at the top of our code up here. Lovely stuff. And we'll just hide that. Hopefully that works. Who knows? Who knows? Okay, so what we want to do is we want to now check that position. So we're going to write a function to check that position. Should I be testing this code as I go? Yes, absolutely. That would be a great idea. So let's do current position equals 1, 3. Actually, let's start at 0, 0. And we know that we want to end up with it as 1, 3. So we're going to say update our position. Instead of saying 11 here, I'm going to define a variable. I'm going to say width equals test data at position 0, and we want the length of that. So I'm going to say length. So I want it to find whatever's at position 0 in test data. So the thing at position 0 is this string here. So it's going to get this string, and then it's going to say, okay, how long is that string? And that's going to be stored in width. And now I can just pass in width. So in our puzzle input, if that changes, it's not hard-coded in. It's not just 11 here, when actually in this, it might be 13 or 25 or something. So it's dynamically getting it, which is much better. So we've got our current position. We're then updating our current position, and we're going to print our current position. Okay, I'm just going to quickly print in here empty string, just so Python doesn't complain. See if this works. Huzzah! Fantastic, it has updated it. Let's also just print out our current position here, just to show that it's not a fluke. Okay, great. So we start off at 0, 0, and then we add 1. So we go down 1, and we go across 3. Fantastic. Everything is gravy. Now, you'll notice that what I've done is I've broken this problem down. I've started by just thinking about how I can update this position. I've not gone in and thought, okay, I need to count all the trees. How do I do that? I thought about this. I broke it down. So update position. I've worked out how to do that. And then that's stored away. That's done. That's easy. I just focused on one little bit and didn't just try and solve the whole thing at once. So now what we're going to do is we're just going to focus on checking our position. So to check our position, we need to have our test data and our current position. So we want position. We also want what should we call this? What is it called? What do they call this? I want my variable names to be good, you know? You know when you get a real good variable name? You'll need to, what is this, a slope, I guess? Call it a slope. Just call it puzzle input. Yeah, it's not really referencing, is it? A map. Let's call it map. That's nice. That's very nice. So we'll call this, we'll pass in the map, which is going to be our test data to begin with. Okay. And what we're going to do is we're going to say if our map, actually, let's do this a little bit more simply. Let's make an X variable and a Y variable. Let's say X equals position at, so if this is our current position, our X position is going to be the second one, so at position 1. So X equals position 1, Y is equal to position 0. And then we're going to say if map at position Y at position X. So if our data here was 2 and 5, okay, we're saying if map at position 2, so down 2, so 0, 1, 2, this one here, and the thing at position X, which is the thing in here, which is this, which is 5. So we're going to count 5 along. 1, 2, 3, 4, 5. So we're going to have this one here. That's going to identify just this dot, because we're saying we want this line, and inside that line, we want the 5th thing inside that, which would be this one here. So we're going to say if map at y, x, I know the y and x are the wrong way around, please don't hate me for that, is equal to a hash symbol, then we know we've hit a tree. And we need to return, let's say, true. No, let's... What are we doing? I pasted this up. How many trees are we doing counter? Yeah, absolutely. So we're going to return... What should we do? Should we just return true? I mean, we're saying check position. That's not a very descriptive name here. Let's update this to tree collision. Has collided with tree. That's a bit wordy. Let's do that. Has collided with tree. Lovely. And so that's going to return true if we have collided with a tree. Otherwise, we are going to return false. Now what we're going to do is we're just going to check. So every time we update our position, we're going to check. So let's, we've got our 0, 0 here. We're then going to say trees hit is equal to 0. Let's establish that right at the start. Current position. Let's do that just here. Trees hit equals 0. And then we're going to say trees hit is equal to has collided with tree. And we're going to pass in our current position. And we're also going to pass in our test data because that's our map. And we can change this to be our actual data when we do get to that stage. Okay, lovely. So we're then going to just keep doing this over and over again. Now, I'm going to do this in a very, very bad way to begin with, and then we will make it cleverer in a second. So I've just copied and pasted this. This is awful practice. Never do this. But this is just to kind of show you that we're getting the position at 0, 0. So that's the top left corner here where we're starting. We're then going to check whether we've collided with a tree in that position. We know we haven't, but we're going to check anyway. We're then going to update our current position. And then we're going to, again, check to see whether we've hit a tree. Now, I should be saying trees hit plus equals, because I'm not wanting to overwrite the value. I'm just wanting to add to it. Okay, let's hit run here. And it is not happy with this. Has collided with tree. I've definitely spelt this wrong, probably. Oh, no. I've done it again. I did this yesterday as well. I've defined this function down here. It needs to be defined before I use it. I'm using it before I've actually told Python what it is. Let's pop it up here with update position, all the gang. There we go. Lovely stuff. So let's hit run here. And we're not printing anything out at all, which is great. Fantastic. So let's print out trees hit. Lovely stuff. And let's run that. So we've got 0 trees hit. When do we hit a tree? No. Okay, so we need to do it one more time and we should get 1 hit tree. So let's just... Oh my goodness, don't do this. Never do this. Okay, let's just copy and paste this one more time. And let's just hit run. Bosh. So we've hit a tree here. So we've got our current position. We started in the left here. We then updated our position and ended up down here. We then updated our position again, and we ended up here hitting a tree. Okay, now this, some of you might be tempted, like, oh, great, that works. I'll just copy and paste this 500 times. No. Okay, so what we need to do is we've established our current position. Oh, didn't want to do that. Now we need to get this in a loop. So we need to do this a certain amount of times. And we're going to, all the time, we're not at the bottom. Okay. So when our current position, this number here, all the time this number here is smaller than the length of this array. So all the things inside here, there's what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 rows here. So as long as it is smaller than 11, because this is position 0, remember. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is smaller than 11. When we get to 11, which doesn't exist, we're then going to just stop. So we're going to say not for, but we're going to say while. We're going to do a while loop because we're not sure this could change in the future. We'll do it condition based. So we're going to say while current position at index 0, so this number here, while this number in here is less than, and we've got the width here, so maybe I'll do the height as well, just to make this really clear. So I'm going to say length of test data while our current position is less than our height, we are going to add to our trees hit, and then we're going to update our current position, and we're going to keep doing that until we get to the bottom. Okay. Now, actually, no, that'll be fine. I had a I had a conflicting thought there, but it's okay. So one thing I just want to address is you might be wondering how on earth I'm getting one, how I'm adding this when this is just returning true or false. This is something I did yesterday. True can also be represented as a 1, and false can also be represented as a 0. And so when we return true, we can actually have Python interpret that as an integer. And if I try and perform maths on it, it will actually just be like, oh, you must mean 1, and it will actually just let me add 1. So even though I'm returning true, I'm actually increasing trees hit by 1 because true can be 1 as well, which is kind of neat. I really like that. This is weird, but it's helpful. It's really helpful. Okay, so from this, in our code here, we should encounter 7 trees. Let's see if that is right. So we've got our 2 functions here. We've got our test data. Boosh. Let's give this a run. Okay, we got the value of 2. Oh no, what have I done? While current position is less than height, and height is the length of test data, trees hit plus equals has collided with tree, our current position and our test data. Our current position then equals update position, our current position and width. Why on earth have we only been given 2? Return true. Maybe I'm being too clever with this. I don't know. Let's every time this loop runs, let's just print. What should we print? Test. There's probably 1,000 better things I could do. Okay, so this is running how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times, but it's only counting 2 trees. So there is a problem with our code. That's very awkward. That's very awkward because we should be getting 7. Now, I'm glad that we did this with the test data because we know that what we should be getting. If we did it with this, we'd have no idea if that was right or wrong until we put it in the answer box and cried ourselves to sleep. So that's good. Now, I'm concerned that has collided with tree. Map y x. No, I'm concerned that we're updating our position all wrong here. Add 1, add 3, and then if position 1 is greater than or equal to the maximum width, that should probably be. Oh no, yeah. If it's greater than or equal to the maximum width, then we want our position 1 to be equal to position 1 minus max width minus 1. So that was working when we just had a smaller one. While current position 0 is less than height, and the height is the length of our test data. Bosh, so that's running 11 times. We can see 11 tests coming up there. Let's pop a little print into our has collided with tree, and let's just print whenever we do this. Let's just print out position. Actually, let's print out map y x. Oh, didn't want to do that. Y x, and let's see where this is going wrong. So let's run this. So we've got dot hash dot. Okay, so it is counting the hashes properly. We're just traversing the map wrongly, which is a bit of an issue. So yeah, all of those should be trees. So we're just a little bit off. I'm wondering whether I actually need to minus this 1. Let's try this. 7. Oh, great. It works. I was trying to be too clever. Why was I minusing 1? So it goes OXO, XXO. So we got OOX. Oh, because we start there. Okay, yeah. OXO, XXO, XXXX. Okay, fantastic. It works. I was just being a dingus, as always. Okay, fantastic. Don't you just love the word dingus? You can really get your speech behind it. It's great. Okay, so this is all working. This is fantastic. So let's come onto here. We've got our test data. It's working for our test data. Let's see if it works for our proper data. And what I'm going to do is I'm just going to wrap this into a function. So I'm going to say def day one, and I'm going to just push all of this inside day one. And day one, we're going to give it our map or our map data. I'm just going to replace test data with map data. Bosh, bosh. Is that it? No, we're going to pop it there. And I think that's it. Okay, so map data is there. Tree's hit, has collided with tree. We've got current position. Lovely. So this is all working really nice. And now what we can do is we can just simply say day one, and we can pass in the test data. So let's just make sure that's working. So I've just put day one into a function here. Obviously, I need to pop this at the end of my code. So let's pop this down here. And let's move this up a little bit. Here, fantastic. I can just hide that now. So this is my code. Look, I've written one line of code. Day one, run it with the test data. And this will now just run, and I get exactly the same. Let's just clear that, because you might not have realized that that actually did a thing. Oh, okay. It's having a bit of an issue. Okay, but there we go. We did it. Got a bit confused there, but it's working. Okay, so now instead of passing day one test data, what I'm going to do is I'm going to pass it data. So let's comment out our test data. Actually, let's just select this whole thing and comment that out. Lovely. And we are now going to just pass in data rather than test data. Let's hit run. Why am I printing? I don't want to print that out at all. Let's get rid of our prints, because otherwise this is going to go manic. There's also, luckily, a handy error that stopped this from going absolutely ballistic. I've been programming in JavaScript, so I tried to put the wrong comment in. That's gone. Where else did I put a comment? A print. Did I put another print somewhere? Yeah, print test. Let's get rid of that as well. Okay, lovely stuff. So I just need to update my read file. Instead of saying day3 data.txt, I need to say 2020/ because it is in the 2020 folder. So let's give this a run. We're running it with our actual data now. So from the all of this good stuff here, we've programmed it cleverly to take lengths of things and work it out for itself. So we've got things like, where is it? Day one. We're working out the length of it. We're not assuming what the length is. We're saying we'll calculate that when we're given it. And so we can update the data and know that Python will respond to that. REPL doesn't want to run my code. Yes, it does. Here we go. Let's hit run. 292. Here is the moment of truth. Oh my goodness. This box, this is the most exciting box on the internet, because you get to put numbers in and it gives you stars. 292. Is this right? I really hope so. Oh goodness. Okay, here we go. Yes, we got a gold star with 5 stars into this. Oh, this is incredible. We're 1 gold star closer to saving our vacation. This is fantastic. Now, it's not over yet, though. We have part 2, and they're about to change the rules on us. And no doubt it's going to be even more complicated to navigate this slope. Let's have a look. Continue to part 2. Okay, breathe. Whew. Time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop, after all. A sudden arboreal stop is a very posh way of saying crashing into a tree. Determine the number of trees you would encounter if, for each of the following slopes, you start at the top left corner and traverse the map all the way to the bottom. Okay, so it's giving us different rules. So this one is right 1, down 1. This is right 3, down 1, which is the one we already did. Right 5, down 1, right 7, down 1, and right 1, down 2. In the above example, these slopes would find 2, 7, 3, 4, and 2 trees, respectively. We multiply them all together, and we get the answer 3, 3, 6. What do you get if you multiply together the number of trees encountered on each of the listed slopes? So we need to edit our code to be able to respond to these different slopes. So let's copy this. So our update position function, we need to think more carefully about now. What we need to say is we need to give it a x increment and a y increment. Okay, and what we want to do is, when on the first one, we were going down 1, so we were increasing the y position by 1. So I'm going to say y increment here. I'm using x and y like on a normal axis, like a normal grid, by the way. Didn't really make that clear. And I'm going to add the x increment here. And then when we use this function in day 1, what we just need to say is update position, and we're going to update it with 1 and 3 respectively. No, we're not. We're going to go 3 across, and we're going to go 1 down. So we're going to go 3 and 1. Now, we've got some different slopes here, so I'm going to store them in an array. So let's come down here and say slopes equals array. Okay, so we're going to have 1 and 1. Lovely. So this is going to be a list of lists. Oh, don't you just love programming? Oh, didn't want to do that. Okay, so we're going to add in our next list, which is going to be 3 and then down 1, which is the one we've already done. We're then going to have 5 and 1. REFL.it is a bit lacking in the hotkeys, or maybe I just don't know them. But in other editors, you'd be able to do this in much quicker. Maybe I'm just ignorant to the functionality of this. I probably could do a quick Google and make this a bit more efficient, but hey ho, we're there now. So I've got my array of arrays here, my 2-dimensional array, and we have bosh, 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 and then we have our ending bracket here. So we've got a list that goes from this bracket here, this bracket here to this bracket here, and inside that list are these 5 lists, each with 2 elements in, and these are our different slopes that it is giving us. And we need to do essentially what we did on day 1, but we need to do it for these different slopes. Okay, so what I'm actually going to do is I'm going to rename, let's say day 1, we pass in the map data, and then we pass in the, let's pass in the slope. And our slopes have the x first and then the y. So we want to pass in our x coordinate, so our slope at position 0, and then we want to pass in our slope at position 1. Okay, so we've updated this. So now when we actually run day 1, we need to say 1 and 3. No, we don't want to say 3 and 1. No, we don't. We want to give it a list with 3 and 1 in it. And if I run this, I should get 292. Yep, fantastic. So I've updated this to work with an array that tells, or a list that tells this how far down it should go and how far across it should go. And now what we're going to do is we're going to create a little loop that will run this over and over again for our different slopes. So let's write a quick function called day2. Notice how I've separated these into nice little functions, so my code isn't like everywhere. And like once I've worked out how to update the position, I just forget about it. Like done. Like I can just close this up. I don't want to know anymore. Has collided with a tree? Worked that out? Great. Gone. Don't need to know about it. I've worked out now all this kind of day 1 stuff. Done. Day 2, what we're going to want is the map data, and we're also going to want our slopes. And what we're going to do with those is we're going to say for slope in slopes, what a lovely, lovely variable names there. We are going to say we're going to run day 1 with our map data and our slope. And so when I say for variable name in variable name, what it's going to do is it's going to use this variable name as it goes through the array. So this has to be an array that exists, this one here. So this is slopes, which I'm going to give it. I'm going to pass it in here and it's going to use it. And I'm going to say for every item inside there, so it's going to look at this item first, which will be this first list, and it will pass it into day 1. And you can see down here, when we pass a list in, we've now upgraded it to work with that. So it will take this list here and it will use it down here as our input. Still following me? I don't know. Hopefully. So for sloping slopes, we're going to run day one. Now, what we need to do is we need to be returning instead of printing from day one. Or we can print as well. We can print trees hit. But importantly, we need to also return that number. So we're going to, from that function, we're going to return trees hit. So now we can say, we can have our own tree counter here. Let's call this trees counter. I could call it trees hit as well, but it's nice to make the distinction that it's a different variable from this one. If I called it trees hit, it would have nothing to do with this. This variable trees hit only exists inside this function. Outside of this function, doesn't exist. So I could use it here as well, and the two would never know that the others existed. They wouldn't conflict with each other. But we'll call it tree counter just for why not. So tree counter, we're going to say plus equals, and we're going to start tree counter at 0. And then what we're going to do is we're going to print our tree counter. Okay, fantastic. So I can now, if I just comment out day one, actually, no, let's run day one as well. Let's run day one. In fact, let's print, let's take some pride in this work, shall we? Let's print trees hit. Why am I calling this day one? It's part one. We're on day 3. Ah, Dingus once again. Let's strut this. Okay, this is all wrong. This is all wrong. Let's rewrite the whole thing. G-darn. Okay, part 2, lovely stuff. So we're going to change this down here to part 1. Fantastic. And I've got part 2 here, print tree counter, and we're going to say, again, we're going to say maybe part 2, trees hit, and then we're going to add the, actually, I'm just going to put a comma. Let's put a comma. If you put a comma, you don't have to convert it to a string. Pro tip. Let's do that, and we're going to just put part 1 here. Part 1 tip. Okay, lovely stuff. So, bosh, bosh, bosh. Let's run this. Okay, so we've got part 1, trees hit 292. Lovely. Let's also run part 2. So part 2, we're going to pass in our data. We're going to pass in our different slopes. And I'm going to be extra about this. And I'm going to say slopes at position 1. So this is at position 0. This is at position 1. So that it just pulls it from that data. Why not? Run. The old trace back. Okay, so I've renamed this and I forgot to update it. So I called this part 1 now. Not day 1. I forgot to update it in here. So I'm just going to paste that in there. Lovely stuff. And moment of truth. Here we go. Run. Oh, okay. Because we're printing it every time, it's actually printing out those 5 times. That's quite cool, though. That's quite nice to see. So it starts off at 81, 292, 89, 101, 44. And we get 607. Why is it printing out with a double line? Double space, that's annoying. Oh, okay, because I put a comma there. Okay, cool. Let's just, sorry, the double space, my brain couldn't handle a double space there. Okay, 607. Is that the correct answer? Is that going to unlock this star for us? It can't be that simple. When I started reading this code right at the start, I was like, this is absolutely nuts. Like, there's no way we're going to be able to do this. But it's been really nice. We've broken it down. We've taken our time. And I'm quite happy with this. So let's have a look. 607. Is this the right answer? Do we have both stars for day 3? Or am I going to have to manically debug this program? Let's have a look. It's too low. It's too low. It's too low. Okay. What have we done wrong? The disappointment is palpable. So 1, 2, 3, 4, 5. We've done 5 slopes. 1, 2, 3, 4, 5. There are 5 slopes there. Our tree counter is 0. For sloping slopes, tree counter plus equals part 1. And part 1 is going to return the amount of trees hit. Okay. Now, yesterday there was some kind of sneaky rule that I got caught out on. Let's have a look. Is there some kind of sneaky rule here? Right 1, down 1. Is our position being reset each time? Let's just check that. Part 1. Our current position is 0, 0. Okay, yeah. So whenever we calculate this, we always start in the top left corner. Okay, fantastic. Right, let's have a look. In above example, these slopes would find 2, 7, 3, 4, and 2 trees. Oh, we've got to multiply them together. What am I doing adding them up? We've got to... This is, of course, it's not working. Fool of a toque. Okay, so for each time we... absolute dingus. So we're not doing plus equals here. In part 2, our tree counter is actually doing times equals. We're multiplying by whatever this is returning. Let's do this with the test data. Let's just make sure. Let's just... Can you tell I've been shaken to my core by getting this wrong? Oh, if only I read the dang question. If only. Okay. So I'm going to run part 2 with test data, and hopefully we will get the answer of 336, which they've given us here, based on this test thing that they gave us at the start. So let's run this. Bosh. And we've got 0 because I started it at 0. And guess what? Things times 0 is 0 all the time. Wow, good maths there. So tree counter, let's start that at 1 because we're multiplying, we're not adding. Okay, let's run that. And everything has frozen. Everything has crashed. Okay, let's clear this and let's run. And please work. Yes, 336. Fantastic. 27342. And it says here it should have 27342. And we get the answer of 336. We are on to a winner here. So let's swap out our test data to our actual data. And we're going to pop data here instead. And we're going to run this bad boy. And we're going to get wowzers. What a number. Okay, let's copy that. I'm not going to try and memorize that. That is, what is that? 9,354,744,432. A big number. Let's pop that in there. Our 607 just seems so piddly compared. No, it was like, yeah, it's a little bit low. Yeah, no doubt about that. Let's see if this is the winning answer. Here we go. Yes, we did it. We nailed day 3 there. Fantastic. I'm so excited. We now have 6 stars. We have done 3 days in a row, and we are 1 gold star closer to saving our vacation. What an absolute ride it's been. A wild ride. No pun intended. So there we have it. 1, 2, 3, all starred up, and I will see you tomorrow for our next 2 stars. I can't wait. Thanks for watching. Oh.